Okay, so just continuing on from our last video. We planned a flight from Torrance to Camarillo, showed you some basic tools inside of ForeFlight. This is the web version of it. And just a quick overview again. This header right here gives us, our total distance, estimated time en route, estimated time of arrival, how much fuel we're expected to use, and then what kind of wind situation we're going to have on the flight. So we're losing, or we don't have some forecast winds, right? So estimated time of departure, ETD, wind forecast is unavailable using historical winds and temperature. So it's giving us a reference to an older wind source, right? So it's that's one of the nice things about ForeFlight is that they give you kind of a heads up when you're not using like a proper winds aloft or a current winds aloft chart for, in this case, the forecast winds. We have some action buttons here, navlog, which we did in the previous video, the briefing, which is what we're going to look at today, files, and then any messages related to this. Again, the date, the time of departure location, Torrance, takeoff info, Camarillo, which is our landing destination, landing distance or landing calculation, landing parameters, landing performance, whatever you want to call it. I spent so much time on that, we'll talk about it. So we could select, okay, we're going to land on 26 left, 0 slope, we got that much space available, it's dry and paved. We'll use magnetic winds. Wind speeds are 5. How come we don't have a... No, that's why, because we don't have current winds. Let's see, how do we get that relatively quickly? We're going to go here, info, and we'll go weather. Oh, IFR over there. Winds are variable at 5, so we don't have a good surface wind. Right? So that's a surface wind. So variable at 5 is kind of like saying almost no winds. We can't say no winds, but we cannot use it effectively for this. So let's just say 260, right, at 5, right? And we're going to use that. Our landing weight is this. We'll use full flaps, safety distance factor, our landing speed, total distance. We should get stopped in about 1,279 feet. Ground roll should end up being 555 feet on the ground. Okay, so total distance. Yeah, maybe I need to define that a little bit farther. So touchdown, okay, and landing is from touchdown to full stop is about 550 feet. From over the runway to actually coming to a full stop, we're going to use about 1,200 feet of the runway to get ourselves fully stopped. Okay, so anyway, that's a little segue on that. Didn't want to spend too much time on that, but maybe it's a +1. Maybe it's a little add for everybody. Again, what's the routing? One waypoint in between, altitude, the kind of flight, weights and balance, fuel, and those kinds of things. What we're going to look at is the briefing, which is going to take us over here. And so let's go ahead and do the briefing. And when you click on briefing, right, it's going to bring up effectively this right here, right? I just have this open in a separate window, which makes it easy for me to get back and forth and kind of show different things. So when the first window that comes up, these are all of the elements that we're going to take a look at. This is roughly our plan, 4,500 in this airplane. We're departing at this time, should take us about 27 minutes. Right, if we leave on time, we should be there at 7:57 Zulu, and we're going via Santa Monica VOR. Okay, there's 18 unread sections. By the way, this is a standard briefing. There's 3 kinds of briefing: standard, abbreviated, and Outlook. Make sure that you know the differences on those. The standard briefing is the legal one that we need to get for each of our flights. And then the first button here, the first tab, is temporary flight restrictions. So as you can see here, we're in busy Los Angeles airspace, and we've got a number of TFRs, temporary flight restrictions, going on. We've got one at the Los Angeles Memorial Coliseum, aka the Coliseum. Looks like Michigan State is playing USC. Okay, and that's on the 21st through the 21st. That's tomorrow. Today's the 20th, right? So, and they'll even tell us inactive during passing time. Super important to pay attention to these, because this is one of the ways to have a pretty good conversation with the FAA. If it's a presidential TFR, you're going to very likely lose your license or temporarily have it suspended, type of a thing. So there's something going on at Wilshire. Hard to tell what it is. We can try to make sense of what's in here. But generically, this is saying don't fly here. That's the bottom line. And what they give us are some of the parameters. It is active during our passing time. So this is part 1 of 3. And then kind of going through this, you can see the little red dot right there. So that's what we're talking about. And so it's really, we just have to not get into that space and really pay close attention and make that turn at the VOR when we're supposed to make that turn at the VOR. Let's see. So this is generic stuff. And they're not going to tell us. They're really not going to tell us what this is for. So there must be something going on in that location about that. I mean, that looks, maybe there's, I don't know, some kind of pep rally for the game. I don't know. There's one now over here at the Paramount building out in Paramount. That's active during our time. That's not going to affect us. Dodger Stadium is active, so there's a baseball game going on today, and so on. So we can kind of go through each of these. This is Disneyland. Okay. Oh, look at that. They changed it. They're making it a permanent TFR. How do you like that? Well, okay. These are supposed to be temporary, but whatever. And so you can see all of these TFRs. If you see a TFR, we want to pay attention to it. Knowing whether it's active or not makes a big difference. Okay. All right. So down here at the bottom is our next link for IFR AirMets. And you'll see that it's going to take us to the next page, which we've kind of gone through those. And so it looks like in this case, there's 2 AirMets for IFR. Okay. This one is active. This one is inactive. So when I click on the first one, it gives us this red out boundary line. And this gives us a pretty good idea of where it is. And I'm not able to click on this to get a better picture, but if we look closely, it's right along the red line. So a VFR flight going into this, may or may not be a good decision. We'd have to look really closely at the weather to see if it's improving, staying the same, or getting worse. Generally speaking, when we plan weather and thinking about weather, flights early in the morning, moving towards later in the day, especially in Southern California, tend to get better in terms of weather versus getting worse. But that's a variable, and it's unique to every circumstance. This one appears to be going on a little bit later, and it looks like it expands a little bit, right? So if we go between the 2 of these, looks like it actually gets shorter, but it also moves inland just a little bit. So for our flight that we've got planned at the time's not scheduled. And the other thing to kind of comment on is ForeFlight does a decent job of kind of finding, kind of letting you know what's current and what's not going to be during your passing time. If you depart late on a flight, huge to redo this, right? Because some of these things will absolutely change and potentially affect your flight. You don't want to go into weather. You don't want to go into a TFR. So it's always a good idea to check and triple check and so on to make sure you're good. So this AirMet for mountain obscuration, which would be effectively AirMet Sierra, this one is active, this one is not active, right? And AirMet Sierra is basically mountain obscuration, which means there's clouds and fog potentially covering up terrain. So that's right on our path. So there's definitely some cloud layers out there. And so on. So now we'll go to synopsis. So there was no unsafe NOTAMs, convective SIGMETs didn't seem to exist, so they've kind of excluded that. These would get turned on if those existed. Urgent PIREPs, there wasn't any of those. And so now we're down to, let's kind of get to our next one. Here's our synopsis. This is our surface analysis chart. On ForeFlight, when you click on this or tap on this, it'll actually open up, and we get a pretty good idea of what's going on. Most of the central United States and eastern looks like they got a lot of weather going on there. It looks like there's a lot of rain falling right now. And then looking back here, it looks like we've got some stuff, some light stuff there, some stuff up in the Central Valley, some stuff up in Northern California. A couple of low pressures, which means, you know, certain things. High pressures generally mean some other things. We've got a stationary front here. Okay. Looks like a warm front that's breaking up. And there's an occluded front here. That purple one's an occluded front, giving you some pretty interesting weather. So this is kind of like a big picture, and the way ForeFlight sets this up is big picture to small picture. So now let's go in and look at the small picture. So the METARs, remember the METARs are the hourly weather, okay? And as you look at this, it's going to give you a lot of the airports in the area, and it's going to show you what's going on with the current weather in the last hour. So Torrance is VFR. Looks like Hawthorne or LAX, Hawthorne, LAX, Santa Monica, Point Mugu, all of those are appearing IFR. Since this is IFR, we could probably draw the conclusion that Camarillo may also be IFR. So if I look at this, nope, I'm actually wrong. It's telling me it's VFR. So CMA, on this date at 6:55 Zulu, it's currently, actually this is old. The current weather needs to be updated. So this is quite old, actually. It's 1819 Zulu. So this is 12 hours difference. I did do this last night. So that's when this METAR was captured. All right. So it's saying, and you should be able to read these. Again, I'm not trying to teach you how to do this now. I'm just trying to help you do the weather brief. But this is a METAR for Camarillo, date and time. It's an automated system. Winds are calm. Visibility is 6. Sky condition is clear. Temperature dew point is 19 and 18. The spread is 1 degree. That's a warning sign right there that we're likely to get weather, right? That's pretty close. When these two numbers get within 4 degrees, we're very likely to get weather. This is barometric pressure, and then everything else after this is going to be what we say remarks. This is kind of, this is the kind of equipment that we're using. It's an AO2 system, which is, it allows for precipitation. This is sea level pressure in inches of not inches of mercury, in millibars. This is inches of mercury, okay, 29.93 inches of mercury. And then this is presented in millibars. And then this long weird one here is temperature and dew point to the nearest decimal. So in this case, 19.4 degrees, which rounds off to that, and then 18.3 degrees, which rounds off to 18. All right, so that gives us that. Let's take a look at cloud coverage. Southern California is certainly getting, down along the border. It looks like it's definite overcast. Kind of moving up, looks like we get a little break kind of where we're at. And then going up a little bit further, we've got that AirMet for mountain obscuration. And then we can kind of scroll forward and look at the different times and see what it looks like at different times going into the future. Make sure you've got the border in there. It's kind of hard to see the border, so some of this is offshore, right? And it doesn't appear to have too much onshore except for down here by the border, and then up here as we get close to San Francisco. And then if we look at the continental U.S., the CON-US is the continental U.S. You may not be aware of that, but it's a picture of the entire U.S. Southwest is just a picture of the Southwest. Okay, coming through from here. This is a decent chart, although it's somewhat, I'm not sure how useful it is in terms of understanding the weather. So based on the altitude that we selected, we're going to be given certain weather. This is visibility, surface winds, and precipitation. So these are surface winds. These can be useful in helping us understand thunderstorms, rain showers. Okay, so we can understand what's going on. It's kind of a surface, a weather depiction chart in some ways. Some offshore weather, okay, that we're dealing with, kind of fast, going to 0900 Zulu, and then looking at the continental U.S., right? And you can look, these are winds, okay, and they're kind of generally going in a lot of different directions. These are all surface winds, 5 knots, 5 knots. So it doesn't look like we have any major blowing, gusty conditions in California. There's one here that's got a gusting, so it looks like 5 gusting to 15 type of a thing when we look at that. Okay. Now the TAF, the Terminal Aerodrome Forecast, this gives us a forecast along our route. Remember, Terminal Aerodrome Forecast is exactly that. It's a forecast, and it's for a terminal area. All right, so LAX is forecast to be this. It reads similar to a METAR. And then these highlighted ones, okay, you'll notice as we go along, the times are changing. And this is what if we departed on time, ForeFlight does a nice job of saying, hey, you should be fairly close to Oxnard at 7:57 Zulu. And if you are, this is what we're forecasting the weather to be, okay, at this time right here. Okay, hopefully that makes sense, right? And then in the future, so for example, if we get to Camarillo at 7:57, Oxnard and Camarillo are right next to each other, by the way. So that's why they're using the same times. If we're trying to get out of Camarillo, right, if we're going to go there and we want to take off, well, if we wait too long, we might get stuck if we're not IFR certified. Okay, so if we don't have our instrument rating. Okay, and it's going to get worse because then there's low IFR as well, which means the clouds come down below 500 feet. So that's our TAFs, which are quite useful. This wind chart is our winds aloft, and because we selected 4,500, it gives us this. This is the valid time, right? And this is our routing, okay? And if you look at this, much of this is going to be a tailwind, okay, as evidenced in our portfolio, in our nav log. So it's about 5 knots of tailwind. That's what that's telling us. The little half barb is about 5 knots of tailwind. Yeah, it's pretty mellow. It's pretty mellow. It's only 5 knots at 4,500 feet. So that's that. It gives us a general picture of what's going on there. So vertical crosswind. So this is kind of useful. A couple of details here. Again, you've got our wind barbs. We've got our altitudes over here and our location across from Torrance to Camarillo. This is icing information. And then if there's any turbulence, it'll show up here. The blue line here is highlighted as the flight path. Tropopause is usually at pretty high altitude. And then this green, this light green, is terrain. Now, this does not mean we're going to be flying or crashing into terrain. What it does mean, as we get and descend down to 3,000 feet or so going into Camarillo, there's going to be terrain around us. Okay, and we have to start paying attention to that because, okay, where is the terrain? How high is it? Well, 3,000 feet in this case. And then where? Is it off our left? Is it off our right? There's a few, some mountainous terrain out there that we have to pay attention to. You could be flying through a valley, for example, but you're going to get this kind of depiction. It's to highlight and make you aware of terrain in the area. Okay, winds aloft. So this is common, kind of a common, nice way of looking at it. And what they're doing nicely here for us is giving us Torrance, Santa Monica, Camarillo at 4,500 feet. Now, this is not a true winds aloft because it is it's computer generated, but it gives us a number. Okay, it gives us some kind of measurement for each of the locations. Okay, so for example, Camarillo. Well, let's use Torrance. Torrance does not do its own weather balloons. It doesn't send up its own weather balloons to tell us what the winds are doing at altitude. These are predicted. Okay, so they're all predicted, but the whole thing about these is that the winds aloft for, over Santa Monica, right? That is a computer generated number that is usually useful. But it distinguishes itself against, weather reporting locations where the data is actually being observed and collected. Yeah, take a weather class and you'll get a little more on that. But the value there is that it gives us some numbers to work with if we're trying to do our wind correction angles at altitude. Okay, departure NOTAMs. This is notices to airmen. This NOTAM description allows us to understand, in this case, things that are not working in the airspace. Remember, NOTAMs are created when the information is too new to make it onto the chart. Okay, so if something changed, hey, there's a crane that popped up near Torrance, somebody's building a building, and there's a crane that sits at 150 feet. That becomes what we call a NOTAM, a notice to airmen. There's a couple of different kinds of NOTAMs, departure NOTAMs in this case. And at Hawthorne, okay, this is the number of the NOTAM. There's a tower light, okay, 1.3 miles east-northeast of Hawthorne at 243 feet, okay, MSL, and 58 feet AGL. So it's not real high. It probably won't be a factor, and that's how many of these NOTAMs are. But we still have to be aware of them, and there's a whole bunch of them to pay attention to. Okay, so there's navigation, communication, service volume, which has to do with radar coverage and how what kind of services we can get from ATC. Obstructions, which is the big one, as you can see here. Special use airspace, runway NOTAMs, taxiway NOTAMs. Oh, at Torrance, taxiways Alpha Bravo Charlie Delta Echo Foxtrot Golf and Hotel. The edge lights are apparently not working, so there's something going on with the edge lighting. Okay, nothing on the apron. So there's nothing there. The aerodrome. Okay, so what's going on with this? Okay, so there's equipment and people working. Okay, so there's equipment working in all surface areas. That probably corresponds to the work that's going on or the NOTAM that's up here. Right, so this is just another NOTAM saying, hey, there's people working on the airport at this time. And then here's another one here, right, talking about takeoff minimums. Right, if you were IFR, this would be something that we would definitely be looking at and paying attention to. Okay, destination NOTAMs. Okay, so what's going on over at Camarillo? Same exact stuff. Okay, en route navigation NOTAMs. Right, so this tells us about the TACAN at the LAX VOR, and then along our route, what else is going on here? So Hawthorne Ventura, NAV, DME. We'd have to go and look that up a little bit. Now, actually, wanted to show you this. You kind of switch. You can see I'm switching back and forth between these, and so this is basically saying, the TACAN is unserviceable, right? That means it's potentially not working. All right. The VORTAC is not maintained, right? So it's this kind of stuff that it's just kind of saying, hey, by the way, this might not be working. Communication NOTAMs, Burbank, and so it's just giving us details on each of these things. In this case, related to communication. Whiteman Airport, Van Nuys Airport, Burbank. It tells us some things that are going on. Remote transmitter, that frequency is not serviceable, and so on. So let's go on to en route. Okay, so this is going to give us BCST system, right? Is unserviceable. Long Beach. This ATIS phone number has been changed to this one here. Oh, that's good to know. Okay, that's actually a good update for me to know. Never would have known if I didn't look at it. Right. So these things become until we looked into some specific airport things, but it's that kind of stuff that is valuable. All right, airspace. Is there any special thing? Are there any things going on? Looks like there's a UAS flying around near LAX in Santa Monica. At Fullerton, Pomona Airspace, looks like there's another UAS. There's a lot of these unmanned aerial systems that are flying in the airspace now, and there's only gonna be more as we move forward as drones start to become more and more popular in their operation. And then this is so runway taxi apron, AD, FDCs, FDC NOTAMs. And so this is another large group of NOTAMs that kind of speaks to, generally speaking, more IFR type operations and, things that are maybe not working, like an instrument approach or a light may not be working, or an instrument approach procedure may not work, or there's an adjustment to a standard instrument departure. There's some things to pay attention to there. Okay, and then there's another general one that kind of throws us into a general category. It's hard to get through all of these. There's so many of them, right? And then there's air route traffic control NOTAMs. And then all of these go through and tell us more stuff about airspace type of a thing, right? Having ForeFlight give us some level of ability to kind of see what's going on here, but it has some value there. And then we circle back to the beginning, okay? So that is a weather brief, okay? And then this would count as a formal weather brief from an FAA flight service station. And so that is the flight from Torrance to Camarillo in a couple of minutes, I guess. A little bit more. It shouldn't take you as long eventually, but practice will speed this up for you, and you'll start looking and being able to see things a little bit quicker the more you practice. So start practicing with these, and keep in mind it's a journey. It's not a destination. Each and every day you're working towards growing and so on. So keep that up, and you'll get there, right? Consistent effort over time is by far better than kind of a flash in the pan and a lot of effort all at once, right? You'll learn more, you'll be better. Okay, anyway, I'll stop chatting and let you all go. Thanks for watching. Reach out if you have any questions, and we'll go from there. Have a great day.